So if you were taking notes, today is called P5, and we might call it 1P5, P2. Why? Because it's in the P5 section and it's worksheet 2. Last time we talked about solving by graphing. This time we are solving with something else. Everybody get your notes up, put a smiley face on them, turn them my way. Should have that done in 5 seconds or less. All right, here we go. So in your notes, label it as P5. And then if you were going to save them, you'd save them as that. All right, what is P5 about? Well, basically it's about solving equations, and there's 3 ways to do it. Day 1, yesterday, we did solve by graphing. Today we're going to be just solve algebraically. So that's this kind. You remember how if you get something factored into this, that you got the answers like staring you right in the face? What are the answers to this one? -3 and -4. Because if you put in a -3, it will work. It'll make this equal to 0, and it doesn't even matter what this is. 0 times anything will equal 0. So you got 2 answers, x equals -3 and x equals -4. All right, I'm going to give you a little more complicated one. 2x minus 5 and 3x plus 4 equals 0. Would you solve 2 little equations and find me the 2 answers? If I were you, I would write them out as little equations where you say equals 0. People try to do this in their head all the time and they goof up the negative. I do it too. Anytime I do stuff in my head, it decreases the probability I'm going to do it right. It's just not quite as accurate. Okay, turn them my way and let me see. Yep. Can you zoom in on it, please? As you get it tightly zoomed. Good. Oh, I changed it to a decimal. That's fine. Good. Okay, I'm seeing almost everybody getting this right, so I think you're on it. And it was add 5 to both sides on this one. 2x equals 5, x equals 5 halves, also known as 2.5. And then this one minus 4 from both sides, and now I have 3x equals -4, x equals -4 thirds. Okay, that's not bad as long as you know how to factor. So if this problem, the original problem had been 6x squared, that's my firsts being multiplied. And then the outside and the inside makes -15x for this and positive 8x for that. -15 positive makes -7x. And then the last's -20. Would you be able to factor that? Do you know how to factor? That's really the question. I've been working on that with you in the top 20. It's got factoring on there to practice. So anyway, if you don't know how to factor, then you don't know how to get it to the red. And if you can't get it to the red zone, so to speak, then you won't be able to solve this equation. So the original problem will usually look like this, and you just have to factor it. What happens if it won't factor? Is there any other way to solve quadratics? Quadratic formula. You just have to use that quadratic formula. So if I change this number to a 19 right here, there are still answers to the problem if I change this 20 to a 19, but it won't factor. And if it won't factor, you're probably going to have to use the quadratic formula then. So you have to know how to handle that. All right, last thing. When you get answers to a question, like I'll give you a simple one here. Find me the 2 answers, and then double check that they actually work. I know that seems dumb, but in Precalc, you've just moved up a notch, right? That's one of the ways that this class is harder than the last class, is that a lot of times on the tests, we're going to give you problems where you can have done it perfectly, and you got 2 answers, then you actually try them, and one of them doesn't work. Happens a lot. That's called an extraneous solution. The solution that doesn't really work. Yes? Good point. There is a little hint a lot of times that there's an extraneous solution. Let me show you what that is in just a second. You should have said x equals -3 and x equals 5. And then how do you actually tell if it works? You actually stick the numbers in and see if it actually works. I put in a -3 here and a -3 here. Okay. Now all of a sudden this part becomes 0 and this part becomes, it doesn't even really matter because 0 times anything makes 0, right? So that one worked. All right. What if this had you'd come out with this. Let's say you had that problem. You got to factor to that. And then you got an answer of -3. Do you get how when you actually put the -3 back in the problem, you're going to have a problem? Why? When I put a -3 here, that part's 0, but I have to put a negative underneath the square root. Do you see how that breaks a rule? So that means -3 is not a solution to this, even though it totally seems like it should be. From all those things I was saying before about how, you set this equal to 0, and so x equals -3. You told me to do that. But the problem is when you stick it back in, it crashes the function. Doesn't actually work, doesn't turn into 0. If you put a -3 underneath the square root, that's illegal. You can't do that. I'll give you another example. Let's say I had this. A lot of people are going to say, well, the two answers for that one that would make it equal 0 are if I could make, here, let me make one more thing just in case there's any math teachers out there watching. Let's say I had that. Okay, now if I choose x equals 3, if I put in a 3 right here, it seems like I have a 0, and a 0 divided by anything is 0, except when you actually go plug the 3 in everywhere, you'll end up with a 0 on the bottom of a fraction. You're not allowed to have a 0 on the bottom of a fraction. That's called undefined. So the moral of the story is, when you get your answers, you should check them, because a lot of times, one of your two answers, when you actually put it in, won't actually work. It's called extraneous, non-functioning answer. I used to play cards with a guy who had an extraneous finger. What did I say about extraneous? What are they non-functioning, right? He had the classic sixth finger. Have you heard of this? He had a sixth finger right down here, and that finger did not work. It was just kind of dangling there. And so he'd like to play cards. He'd put his hands out over the poker table, and he would flick his dead finger back and forth, bing, 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 bing. It was incredibly disgusting. I obviously still remember it to this day, and it really threw your game off when you're playing poker when there's a guy flicking around a dead finger. So he probably won lots of money from distracted people. Genius plan. Anyway, in this country, he was probably I'm just guessing, but he's probably not born in this country, because in this country, if you have the sixth finger at birth, they will take it off. And so if you look at the heel of your hand, if you have a little scar there that you can't, only had one kid find a scar that they were like, oh my gosh, maybe I was one of those people. And it's like, 1 out of every 10,000 or 100,000 babies born have a sixth finger, called polydactylism. Anyway, and in this country, can you imagine on the playground if you had the sixth finger? Like, oh my gosh, you'd be like a pariah. So they take it off. And the only hard decision would be, in an incredibly rare circumstance, what if the sixth finger actually worked? Would you let your kid keep the sixth finger? If it worked, if it was functional? Or would it just like freak the family out too bad? Gotta take it off. But it's really kind of sad if you think about that. It would just be for other people's benefit, not theirs. Anyway, that's the extraneous finger story, and it goes along with not functioning fingers, which goes along with not functioning answers. You get this answer and it doesn't actually work. So watch out for that, because it's going to happen. All right, a couple more thoughts. Pausing for just recording again. All right, so we are going to be solving problems like this, and a lot of people don't know how to do this. Either you do or you don't. Would you try to solve this for me right now? And if you know, it's simple, and you'll have two answers, and it'll be done. If you don't know, you'll probably be able to get one answer, but you won't know about the other one. You guessed on one of them, I can tell. You got one of them right, but you guessed on the other one. This is one of my top 20 things that I think kids should know. I know you saw absolute values before. And you probably solved simple absolute value equations. Nope, thanks for trying. You got them, I think. You got them, I think. Nope, you got one of them. You got them. You got them. You got them. You got them. All right. You did not. I'll show you how. You just copied the problem wrong. X minus 3 equals 6. Okay, so here's what you do. Would you agree what's underneath the scribble here could be a 6 or a negative 6? Either way, what's underneath the scribble could be 6 or negative 6, and it would work then. So then what's underneath the scribble should be equal to 6, and what's underneath the scribble should be equal to negative 6. That's how we always do this. We set up two equations for it. And what is underneath the scribble? X minus 3. So right here I should say x minus 3. Notice that the difference between these is only one thing. This is identical equation to this one, except for one thing. Do you see it? The negative right there. Now solve those two equations and you'll have your two answers. That's how you do it. Now you've just learned one more of that top 20. And it seemed to me like only about 5 of you knew how to do that. You need to wake up or I'm going to put you right here and dump water over your head. All right. Is that a 9? You foreigners. All right. You add 3 to both sides. I'm having trouble with, like, I have people writing their 7s in weird ways and their 9s in weird ways. I'll show you. It would look like this. And tell me which country writes their 9s this way? Switzerland and France. Okay. And I'll tell you something about the Germans. The Germans like to make their 1s like this. What does that sort of look like? A 7. But their 7s, to be able to tell the 7s apart, the 7s, they go like that. Now that's a 7 in German. So anyway, I got a German this year, and I got a person from Switzerland. A Swiss? No, that doesn't work. Is it a Swiss? Okay, cool. Yes. Russians also do 9s like that. Okay, there we go. Okay, so anyway, 9, and then over here plus 3 and plus 3, and this makes x equals negative 3. Two answers, that one and that one. And 2 seconds ago, I just told you that you should really go back and check your work because there's a chance that one of these won't work. The 9, when I put it in. 9 minus 3, that actually works. Cool, I checked it. I know 9 works. Now negative 3. Negative 3 minus 3 makes negative 6. Absolute value of that is 6. It works. Okay, I double checked them. Now, do you have to check every one? It's kind of a question of profiling. Now, we want to be careful not to profile in the airport and only check people who look kind of scary to us for like bombs and other things to get on the plane. We don't want to profile. Why? Because then all it takes is to have you just have to recruit somebody who doesn't look scary, and then they can get in on the plane and make the plane blow up. You have to check everyone, okay? In math, it's not like that. We can profile. It's legal. We want to profile problems that have square roots in them. Because if that square root ever comes out negative, that's a problem. What's the other kind of problem we want to profile? Problems that have a denominator. Do you get that if I think the answer is 0 and I put it in here, I'm going to have a problem? Because I have a 0 on the bottom. Watch out for those two things. Square roots can be crashed, and therefore it's likely when we give you a problem that has a square root and you check it, a lot of times one of the answers doesn't work. And the other thing that can be crashed is fractions like this. So I would profile those two kinds of problems, and I wouldn't worry about the kind that don't have square roots or denominators. If it doesn't have a square root and doesn't have a denominator, I can't even think of a way to crash one right now. Okay, it probably can be done, but you won't have to worry about it. All right. So now let's do a quick little summary. Oh, wait, I should change one thing, otherwise you could say that I didn't factor that all the way. There we go. There's a factored answer. Is it going to be able to work? Can I set that up this equals 12 and that equals 12? No. It only works if it's equal to what? 0. So you'd have to get it solved so there was a 0 over here. All right, so let's say I've got it factored now, and now could I check what the answers are really quick? Go ahead, find me the two answers for that one. And then find me the two answers for this one. Remember, you're going to set this equal to 5 and this equal to -5. You'll have two equations to make, and you'll get two different answers. A little quick check to see if you're on top of it so far. I'm going to pause for a second while you try those. All right, so here's how you should have done them. You should have set this equal to 0 and then solved it. 2x equals 5, x equals 5 halves. This one, set it equal to 0 and then solve it, x equals 3. 3 and 5 halves. Raise your hand if you had those two right. Good. Neither one of those two crashes it. Did I even have to check? No, not really, because there's no square roots. And what's the other thing I'm looking for? Starts with a D. Denominators. All right, good. This one, I'm breaking into two equations. 2x minus 3 equals 5, and 2x minus 3 equals 5 again, right? No, that'd be doing the exact same thing twice, which would be dumb. There's only one difference, though. In fact, I think it's not a bad plan to write it out exactly the same both times, and then just throw in an extra negative right there. Get what I mean? It's identical except for that. So it saves you time. Then you solve both equations, and you get this r. Could you turn yours my way because you had them right so I can read them to everybody? You will get 4 and -1. Raise your hand if you had those correct, and that's most of you. Okay, good. All right. Last thought. How do you solve this? Square root of x plus 3 is equal to x. Trying to get the x's alone. Anybody have an idea how you start? Yes, ma'am. It's a good guess, but no, that's not it. Thank you for trying. You square something. You square the x that you're warm. If you do something to, there you go. If you do something on one side, you got to do it to the other side. You square both sides. Why? Because that gets the square root out of there. And then you'll have something more normal. X plus 3, because squared and square root just cancel each other out, see? X plus 3 equals x squared. And now, how do you solve this kind? Well, if you were graphing, you could graph both sides and see where they cross. Today, you're not graphing. So today, you have to solve it and set it equal to 0. Do you remember how if they're equal to 0, then you can factor them, and if they don't factor, you can quadratic formula? All right, so I'm going to set it equal to 0. Notice I'm going to move this junk over to the other side, even though there's two things to move, because otherwise my x squared would turn negative, and I don't want that. So I'm subtracting x from both sides, and now I have 3 equals x squared minus x. Now I'm going to subtract 3 from both sides, and that got everything off that side and over to the other side. And there we go. Now, if that factors, cool. I get two answers really quick and easy. If it doesn't factor, quadratic formula. All right, I've taught you everything that you need to know for today. I'm going to pause for a second to make sure I'm really done. I got a good question. If I get an imaginary number answer, that's going to mean that there was a negative underneath the square root, right? Then in that situation, we're saying there is no real solutions, okay? So now, let's say you get an answer for this thing. Is this one of the kind you have to double check? Does it have a square root in it? Yes. So it's one of the kind that could easily turn out to not work. Let's just finish this one the rest of the way. So 0 equals, factor this puppy, x and x, and how do I make a 3? A 3 and a 1. And can I actually make this equal negative x in the middle with any combo you can think of? No, so it won't factor. Therefore, since it won't factor, I'm going to use the quadratic formula. Yeah, I got to have this puppy memorized. X equals negative b, which means negative of -1. That's the b term. Plus or minus square root of b squared, which is -1 squared, which is 1. Minus 4ac, and I always just put parentheses in for those and fill it in later. All over 2a. 2 times a, and a is 1. That's just 2. Now I go back and do the ac. A is 1, and c is -3. There we go. Does this have a negative underneath the square root? No, because those two negatives are going to cancel. X equals 1 plus or minus the square root of 13 all over 2. There's my two answers. Now, in this case, they're too nasty to have to go back and check them to see if they would work. Can you imagine trying to plug one of those in? Remember, there's two answers. One's with a plus, and one has a minus there. Plus minus really doesn't exist. It's really just telling you to do it once with plus and once with minus. Okay? And those two answers, if you plug them in here, I can tell you that the one that's 1 minus the square root of 13 all over 2, do you get that that'll be a negative number? Because you're going to take 1 minus the square root of 13, and that's going to be bigger than 1. Therefore, you'll have a negative number. As soon as I know there's a negative number, do you get that there's a chance I could make that square root turn out negative there? All right, so in fact, I'm pretty sure it actually would crash this function, and therefore, one of those two answers is probably extraneous. So we won't make you check anything that nasty. Okay? But it was a good time to check because it had a square root, and it actually does have an extraneous solution, the one with a minus. Okay, that's all I have for the video for today.